Okay, so I'd like to go over this problem here where it asks to find b and c that makes this function continuous. Right now, one thing is we have a line and a parabola, right? Each of those individually is continuous everywhere, right? But now we have this piecewise function, right? So before we actually get into trying to solve this, let's kind of take a look at what it is that we're actually looking for, right? What do you mean continuous, right? So let's take a look at the graph here. Right, so if you notice the graph, right, now this is, we're here on Desmos, right, and I have the negative 1/2 x, absolute value of x is less than or equal to 2, and you see that as this red kind of line here, right? Now that one is fixed, right, that one is not going anywhere, right, those are, the constants b and c show up in the parabola. Right, and notice absolute value less than 2 is the values between negative 2 and 2. Right. Now for this one, x squared plus bx plus c, now b and c do vary, right? And as you can see here, so I'm going to change this. I have a little slider here that allows me to mess with the values of b and c. All right. Okay, so we want to see which values, right? What I'm looking for is, you notice here as I change one, these are working in conjunction, right? You can't just kind of, all right, that one looks like it's it, but the other one isn't right. And if I change C, right, so they were kind of working together, right? So I need to find a way where both of them, right, are in the mode where, let's say here, or actually, where we're in that mode, right, where they are connected on both ends, right? And now how do we do something like that? Okay, so here, let me go back to my paper here. Oops. Okay. All right. So the first thing is we need to interpret this absolute value. Right. Now, if we notice here, right, what we saw that was between 2 and negative 2. Right. That was for values of x between 2 and negative 2. I wrote it in the middle just so it kind of looks like our graph, where on the here on the other side we'll have, all right, x squared plus bx plus c for x less than negative 2. Right, that was on the left side. And then on the right side of 2, the parabola is part of the graph again, right, where x is bigger than 2. Okay. All right. And now here is where the limit, the definition of continuity comes into play, right? We know 2 is defined, right? F of 2. Or let's start on the left side, f of negative 2. Right? That value is here on the line, right? So that value of f of negative 2 is equal to negative 1/2 times negative 2, which is equal to 1. Okay? All right. Now, in order for this to be continuous, right, we get something like this. All right, we need this to be true. Right, now if we look here on the left side, right, that would be from the negative side, right, left side, as it approaches negative 2, this comes into play, right? So we'll have from here, limit as x approaches negative 2. From the left side, we'll have plus c. All right, and on the right side, we have the line, which is the function value itself, right? That'll be 1. Right, because it's the line, the value of the line. And the limit of that, since it is linear, a linear function, you can just plug in the value of 1. All right. Okay, so cleaning this up here, just kind of simplifying, we get 4 minus 2b plus c is equal to 1. All right, and on the other side here, the other point that is of interest is at 2, right? F of 2 takes on the value right, from our piecewise function, right, the linear part. So that equals to -1. Okay, and again here what I want to look at is the limit as x approaches 2 from the left side of f of x is equal to the limit as x approaches 2 from the right side of f of x. All right. Okay. All right, and then from here, from the left side, right, we're approaching it. That's going to be the value of -1, right? Left side values that are less than 2, and that is the linear part. And on the right side, values that are bigger than 2, right? That is the quadratic function here. So we can just plug that in since it is a quadratic, it's a polynomial. I'm not dividing by 0, all right? So I'd have no problem in it just plugging in. Okay, and then we have -1 equals to 4 plus 2b plus c. Okay, and so now what we have is lift this up here. I'm trying to get all of it. Actually, let me just rewrite this. My light's in the way here. Okay, let me just rewrite both of those equations here. So we'll have 4 minus 2b plus c equals to 1, and we have 4 plus 2b plus c equals to -1. All right, and what I can do here is I'm going to subtract 4 from both sides. -3, subtract 4 from both sides, is -5. All right, and now what I have here is a system of equations in the variables b and c. All right, I have 2 equations, 2 unknowns. Perfect. I can solve for b and c uniquely. All right, this one works out nicely. I can just use the elimination method where I add both of these here, and we get 2c is equal to -8. Divide by 2, c is equal to -4. All right, so I'm halfway there, right? I found c, and then plug it in to any one of these. Let's plug it into the first one. All right, c is -4, and then I'll solve for b. All right, add 4 to both sides. -2b is equal to 1. Divide by -2. And b is equal to -1/2, right? So both of these values, right? And we can double check, but my process here used the limit, the continuity definition, right? As we discussed, as was covered in this class. And now you could see how, let me just bring the graph back again. Okay. Okay, there it is. All right, as we can see from here, right, as you'll see from the graph, b is -1/2, c is -4, and you could see that those are the unique values, right, that would make this particular piecewise function continuous across the whole domain being from -infinity to +infinity. Okay, thank you.